Hello, my name is Priyan Kotwal and I'm presenting my MSc Practicum project Integration of PQC algorithm in Resource Constraint IoT Communication Protocol MQTT. The aim of this project is to integrate quantum safe cryptographic algorithms into MQTT communication for resource constrained IoT devices, ensuring that secure communication remains possible even in the post-quantum era. So nowadays IoT devices are increasingly vulnerable to quantum threats because they are first of all they are resource constrained and often uh, the classical cryptographic algorithms like RSA or ECC are used, which can be easily broken by quantum threats like the Shor's algorithm. So, while there is work on PQC for constrained devices, a very little focus on securing the data in transit through IoT protocols, communication protocols like MQTT or CoAP. So, here my project addresses this by implementing an integration of Crystal's Kyber algorithm in MQTT, which is a lightweight messaging protocol, which is most commonly used in IoT. So while creating a secure MQTT communication with MQTT, our step-by-step objectives are to uh, first is secure communication between uh, the ESP32 and which is a IoT microcontroller and the Raspberry Pi using the Kyber algorithm. So next we will implement on-device key generation on ESP32 and then transmit the public key to the Raspberry Pi. Then the encapsulation process will happen on the RPi and it will generate a secret key which will be sent back to ESP32. So this would ensure that both devices derive derive the same secure shared secret for further communication. So for the hardware setup, we have used ESP32, which is emulated on Wokweave platform, which is a MQTT client, and Raspberry Pi OS installed on VM as MQTT server. So, so, um, so for the MQTT broker, we have used a public broker called broker.hivemq.com, and for the PQC implementation, um, I have referred multiple GitHub repositories like PQ which has the Crystal Scaber implementation called MLKM 512, and PQ NTRU for the NTRU implementation. So here is some information about the two post-quantum algorithms, Crystal Kyber and NTRU algorithm. So Kyber is one of the standardized algorithm by NIST, which is known for its strong security and high efficiency. And the MTRU was one of the oldest algorithms proposed in 1996. It is a lattice-based and optimized for small key sizes and faster key generation. I chose Kyber 512 for implementation as it balances performance and security for the IoT devices. So here is how the quantum secure MQTT handshake works in this project. So in the first step, the ESP32 generates a public key and it publishes to a topic. Then the Raspberry Pi subscribes to that topic processes encapsulation on it to generate a ciphertext and a shared secret. So after that, it sends the shared secret back to the ESP32. It derives the shared secret, which ensures that both devices has the same shared secret, which can be used for further communication between those devices. So here it's shown the implementation workflow. It starts by setting up Wi-Fi and MQTT connection on the ESP32. It generates public key, and then it's the same process. Yeah. So while implementing this, we faced a few challenges. So the first challenge is the resource constraint. So integrating computationally intensive algorithms like Kyber or NTRU in such low power devices, so it faces significant challenges of battery consuming and um, RAM and all. So there are more such challenges like dependency management, latency, reliability, and integration of protocol. So after implementation, we successfully demonstrated the Kyber algorithm between ESP32 and Raspberry Pi via MQTT protocol. So both devices found to be derived the same shared secret, confirming the integrity. So we used a public MQTT broker showing the approach works in real world conditions. The performance metrics are also calculated to measure the time required to create the public key and encapsulation process and decapsulation process and all that. And the memory usage for that is also calculated. So this project proves that the post-quantum cryptographic algorithms can be integrated into MQTT for the security of IoT communication, even uh, even on such low power devices. So in future um, we can use the shared secret for encrypting the message payloads using any other algorithms like AES or any such that. So and running tests on actual physical hardware can face different results. And in the IoT communication, we can also integrate the post quantum digital signature algorithms like dilithium or Falcon. Yeah. So now I will show you the live demonstration of our algorithm. So this is the Workbee platform which emulates the ESP32 microcontroller. So we'll run this code, and now this is the virtual Raspberry Pi OS. Here we will run the Python script rpy kyber subscribe.py. So in ESP32, uh, here in this function we are generating the key pair, and it will be published uh, at the topic which will be subscribed by the Raspberry Pi to collect the public key. And when the Raspberry Pi encapsulates and sends the shared secret, that part will be handled by this function callback. So here we can see the public key is generated, and the time required to generate the key is given as 5.27 milliseconds. And here it collected it received the public key on this defined topic, and the time required for encapsulation is calculated. This is the derived ciphertext, and this is the shared secret key. So when this shared secret is transferred back to the ESP32, it confirms that both devices now share the same secure shared secret.